Hello. So today, I'm not doing much. I just finished my discussion with my team group for volunteer for next January. Right now it's November, and in January I have a like a volunteer program that I have to do with a group from Yonsei University. So yeah, I just I just did a discussion with them. Um, Other than that, I haven't done anything productive really. Except uh, I slept in the day on at the I mean during the day I slept maybe around 10 a.m. to um 3 p.m. I slept. It's not the best time to sleep, but I didn't sleep the night before because yes, I mean I did live stream last night for doing my quantum um relativistic quantum mechanics, so I didn't sleep last night. To be honest with you, I'm not in the mood for studying, but oh, and also actually, I sleep until 3 p.m., right? And after that, actually, I register for a passport. I register online for making a new passport because I plan to go to Malaysia to visit my grandma. So I have to register first, right? And I have I saved the date for 12th December, if I'm not mistaken. Yeah, 12th December. Yeah, so basically those are the things that I did for today. Not productive enough. It's I think I'm gonna crush my GPA for this semester. I don't know. Wait a minute. You know what? Let's watch PBF Digital Studio. I
Have you ever asked?
I'm interested in this.
So what is ClickUp? ClickUp is an all-in-one productivity software where you can manage everything and anything related to your work.
Every good nerd knows that E equals MC squared. Every great nerd knows that really E squared equals M squared C to the power of 4 plus P squared C squared. But what does that even mean? Oh, I'll tell you.
Because I'm doing this relativistic quantum mechanic project, right? And it's electron and positron annihilation, and many part of this calculation I use the relativistic energy relation, which is um, e this formula right here. This formula, I use this formula a lot in the calculation, and in this video he explains that there is an extension of the equation. So I'm thinking, what if I put that um, put this new formula into my calculation? What will happen? Of course there will be something new show up in the calculation, right? And I wonder if it's something advantageous to physics development. I don't know. I'm just I thought maybe I can make some contribution to physics. So let's watch this video.
But today, I'd like to invite you to an even higher level of nerddom. There may be even more add-ons to Einstein's famous equation that will make even the greatest nerds quiver in their nerd merch, if they turn out to be real, because they could point the way to the quantum structure of space.
It's actually called doubly special relativity. Let's see if it's exists somewhere.
Now that we've delved into the predictions and experimental evidence of doubly special relativity, let's turn our gaze to another fascinating concept, de Sitter relativity.
Wait a minute. Actually, the sitter, I heard about it a lot, and it's something related to general relativity. And I see, I saw MIT. I'm wondering, that time I was wondering what the MIT undergrad um, write as a as a thesis, or as a yeah, as a thesis, right? I'm wondering what kind of um, thesis an MIT student write. So I check in the internet, and I find a lot of them write something about de Sitter relativity. So I'm wondering, what is this? Let's watch.
De Sitter relativity is an intriguing framework that naturally incorporates an invariant length parameter. Because of this, it can be seen as an example of doubly special relativity. However, there's a fundamental difference. While all doubly special relativity models involve a violation of Lorentz symmetry, de Sitter relativity maintains this symmetry as a physical constant. In usual doubly
This is
special relativity models involve a violation of Lorentz symmetry. De Sitter relativity maintains this symmetry as a physical constant. In usual doubly special relativity models, the frameworks are only applicable at the energy scales where ordinary special relativity is expected to break down. This creates a patchwork approach to relativity, where different rules apply at different energy levels. In contrast, de Sitter relativity offers a more unified theory. It is invariant under a simultaneous rescaling of mass, energy, and momentum, making it valid at all energy scales. Imagine a universe where the rules of physics are consistent no matter how high the energy levels climb. This is the promise of de Sitter relativity, a seamless integration of principles that apply universally without the need for adjustments or exceptions. This breakthrough could redefine our understanding of the universe, providing a more cohesive framework that may unify various aspects of theoretical physics. First attempts to modify special relativity by introducing an observer-independent length were made by Pavlopoulos in 1967.
um,
Estimating this length
I don't understand, to be honest. There are many types of relativity. Why? Oh, oh no, actually, it's the Sitter space. The thing that I see MIT students do, it's something about the Sitter space, actually, not the relativity. Maybe it's the same thing, I don't know. Mm, I'm wondering, I register for a permit to the faculty, a permit for me to go abroad, you know, permit for me to go study in another university in a special program, and I'm still waiting for the permit, and it says here it's still getting reviewed. I'm sorry. That yellow one, still getting reviewed. Uh, Based on the estimation of the, I also send in the past I sent a permit also, and it took 3 days to be accepted. So maybe tomorrow, it's supposed to be tomorrow, based on the fact that my last permit took 3 days. So should be tomorrow. They will finish the to accept the my mm, to accept me to go abroad or not. Most likely, there's a reason why they shouldn't accept me, and that is because I already sent a permit long time ago, and I didn't, I changed my mind and I didn't go abroad. So that's that's concerning, because this thing is only for people who hasn't registered previously even once. I'm not sure if by register here means asking for a permit like I am doing, or another type of registration that actually happens after this, after I get the permit. So I don't know which one. So I hope I can still get the permit, and just I you know I really want to study outside of this university. Why? Because I don't know, so that I can put something on my CV. It's actually kind of, the reason is actually is very simple. I'm you know I love space. This is why I took a physics degree, physics major, because I love space. In the high school, I likes to see at the star, especially because in my place, it's there's no light pollution because I live in a village, so I can even see the Milky Way if there's no moon, for example, to show, that's how dark my village is. And sometimes I took the photo of the star with my phone. I can actually do it. I set the settings so that I can, you know, uh, so that I can, what do you call it? Um, Gather the light of the star more on the phone. So, wow, that's really beautiful. So at first, so if you take a photo of stars or Milky Way on the phone, it will not it will not be very clear, and there are some stars that you'll miss. But if you change the exposure, you will. Wow. I mean, this web is I don't remember it to be this accurate. I thought this is just some random detail that is actually not a real star, but it actually is a real star. Look at that. I can click on it. That's that's amazing, I think. Wow. Is there a star named after me? I'm just wondering if there's any. Wow. What is a Rian field? Operation Brush. Where's the star? The star, right? That's is this right? What am I watching here? Why there is no sound? Di tempat maha tinggi. How can I return back to the, what is this? Observation. Nothing interesting here. What about November? What about October, December? What is eunomia? Wait, I just saw some satellite here somewhere. Or cosmos. Oh, no, that's not right. Starlink, look at that. Where's Libra? Oh, this is Libra. This is my constellation. My constellation, Libra. Let's see the. Wait. No. Why is it? Yeah, back to real time. Where's my Libra? There you go. I don't have any like a huge star in my constellation. It's just these are a not so bright star. Unlike Virgo, Virgo has this Spica star. Spica is quite a, you know, it's you can see Spica in, oh, look at that moon. what do you call it in English? I don't know. Moon eclipse? It's no, it's not moon eclipse. This is not an eclipse technically. Wait, it is an eclipse. What do you call this? Lambda? Oh yeah, it is lambda. Oh, oh, there's also okay. So let's check my name again. Ryan. Let's see, also known as this. Let's check it on the internet. Oh yes, it exists. What is this? NASA. It's from NASA. Small body. Is there an English version of this? Oh yeah. What? Why is it like this? Oh, it says list of minor planets. But mine is not a planet. Alright. When did when did mine discovered? Oh, 1999 by linear. What is a linear? Linear satellite. Yeah, no, I don't have time to check on that. Let's check on speaker, cause you know speaker. Hatsune Miku has a song about this. It's the brightest. Oh wait, let's check on Libra again. Which one's the brightest? Is it this one? That's a long name. That despite its beta designation, the brightest star. Well, I mean, is name beta implying it's not a right? What constellation is this? Scorpio. Interesting. What is this? Sigma star? Sigma Libra. It's not in the Wikipedia. Okay. Yeah, this is the only bright star of it. But Spica is. Let's check what about this star. Alright, I know this guy. It's Neoplatonism, something about that. He's a prophet and also God, I think. So, yeah, this constellation is unique. Corona Australis. Is this a constellation even? Oh, it is. Corona. Corona of what? Corona of who? Is this a weapon? Telescopium. That's very weird. This is a fire. What is this? Is this also a telescope? Norma. Norma constellation. What is that? Right angle. Oh yeah, yeah. It's kind of. But looking at the star itself, it's not a straight. It's not a straight line. It's not even. Yeah, it's not a straight line. So that's a bad. It's a bad representation. We have lupus here. I think this is a dog. Centaurus. And then crux. I'm not a fan of the position of this cross, but okay. Wow. I didn't I didn't know any of this constellation exist. This is new to me. Oh, this is the thing you use to measure the height of the sun, right? Or near the equator. Or maybe also stars. Or this is what you use to what is this? I don't know actually. Is this a Caesar? No, I mean a Caesars? Caesars. Oh, it is compass. Yeah, yeah, yeah. It's for drawing a circle. Yeah, and we have a dog here. Interesting. What else do we got? What is this? Sails of ship. Why don't you just include it on the ship itself? Karina. What is this? Yeah, why don't you just combine it all at once? Oh, this is the compass that we are talking about. Is this a small ship? Oh, it's a table? How is it a table? It doesn't look like a table. Oh, it's a flat mountain. Okay. What is this? Oh, it's a wheel. Or something you put in front of your telescope. Is this a clock? Yeah, it's a clock. Pendulum clock, yes. What is this one? An eel? Or a river? Oh yeah, there's a human there. Is this a tabernacle? I mean, the furnace. Okay. I thought it's, what do you call that? Ark of the Covenant. So this furnace is made out of only two stars, and it's a straight line. How can you, like, looking at it and then say, oh, it looks like a furnace? Out of all things that you can name it, you choose a furnace. Is this also a dog? If Canis Major is a dog, then what is a lupus? Is it the same thing? Oh, it's a wolf. Oh, there's another dog in here. Canis minor. Oh, Canis is a wolf again. Wait, if Canis major is a wolf, Canis lupus is the name of. Then what is a lupus? Oh, it's a wolf still. Alright, there are many wolves in the sky. Is this Taurus? Oh, it's a bull. I know this guy, Aldebaran. It's quite bright in the sky also. How Libra looks like. That's so lame. Virgo is a woman? I didn't know that. Is it Latin for maiden? Does it have anything to do with virgin? Because the name is similar. Virgin and Virgo, you know what I mean? Venatici, Canis Venatici. Yeah, I guess it's a wolf again. Oh, there's also a dragon. Ursa is a bear, right? But why does it looks like it looks like a dog again? So actually, Polaris is not exactly on the on here. It's slightly off axis. So actually, there is no star exactly in the here. The closest one is this one, and it's called that. You know, but the brightest closest one than any other star. Hercules fighting with the snakes. I think, if I'm not mistaken, Hercules fight with snakes at a young age, right? When he was a baby. Why is there a horse head in here? But then next to it also a horse. That's, you know, you can actually extend this Pegasus and then say, oh, this is the head part of the Pegasus, and just extend it. Why is both fish connected to this line? Oh, it represents two fish getting caught. Oh yeah, connected by one cord. That's, where do you get that idea, dude? What about this one? Sea monster, also known as sea monster, the whale. Oh, this one, very interesting. When I watched this video first time, maybe 5 years ago, it really reminds me of sky and space and physics. It's Apollo is the name of the program the US did to send human to space. The first program. The second one is, what is the sister of Apollo? Who is the sister? Artemis, right? Artemis. Yeah, it's Artemis. You know, I'm interested. The first time I was interested in space was because this comet. Sadly, I didn't see it partly maybe because actually neo-wise in Indonesia is on the horizon, really really close on the horizon, and also at that time it was afternoon, and also at that time it was really cloudy, so I cannot see the comet at all, maybe because it doesn't even reach my horizon, like it doesn't even part of my dome of available sky, or maybe because of the light of the sun, of the afternoon sun, um making the sky very bright and make me unable to see the comet. So actually when this comet um show up in the news, I was really excited because also at this time I'm watching this um anime called Your Name, or Kimi no Nawa, and it doesn't, it does Kimi no Nawa didn't released. I mean, Kimi no Nawa released way long before Neo White's Comet show up, but I watched Kimi no Nawa near the time of that comet supposed to to show. So when when I saw the news that time, I was really excited, and I study a lot about how to capture night sky. I learned about all of those. In the end, I didn't capture it, but I do quite. I quite. I'm starting to taking interest in astrophotography. I follow many of these social media content creator of astrophotography, study how they took the photo. At first I used this this big camera that my father's own. Sometimes I also use my own um, phone, or you can actually change the settings into so that you can take more exposure of light coming in of your phone. And also I have a tripod tripod in my home because my father was a photographer um in the past, so he has this tripod, so I can use this tripod because you need a tripod if you want to capture the night sky so that your camera doesn't shake a lot, right? You need that stability to and also to let that camera take as much light as possible to make the sky bright. So also so that you can capture the Milky Way, because that's the interesting part of the actually I have this picture right here. I can show it to you. My first, I don't know, I'm not sure if it's first. Actually, I didn't take a lot of picture actually. I quit, just you know I started this and then I quit. So I didn't do this for long. Oh no, I don't want to show you my Instagram for now, but this is the photo that I took. Isn't it beautiful? That's uh, that's the Milky Way, as you can see. You can see the Milky Way, right? And this shiny part on the ground is actually the you know there's this shiny part of the ground. Wait, let me make it focus first. Yeah, okay. This shiny part of the ground is actually a not a city. it's a city, but a small city. So the light from that city make most of the stars below this Milky Way are like disappearing, which is kind of so. This is another photo. Yeah, and from that, I'm interested for in physics. So that's why I took physics in university, and here I am now, hating my life every day because of it's very hard. Physics is very hard. Also, part of that maybe because I'm not that smart. Also because I'm lazy. All right, I think this is it for the video. See you guys tomorrow. Well, by tomorrow I mean today because now it's 12:13. So I have to make another live stream for today also. So yeah.